it's getting quickly to complete the syllabus. Okay, so unit 1, we completed entire 8051 microcontroller architecture. Actually, you people listen, we are focused by your assessment 1 and assessment 2. Everything is through online only. So our college have some suggestion to give assignments and quiz for you through LMS. So today I decided to put an assignment for you people, and the assignment date will be till the end of the month. You have to submit. So everything I will mention it and I will upload in LMS. So complete it and upload it, because assignments, quiz, assessment, for each and everything you have the marks. So collectively we will calculate 50. Last time one assessment you have written, then the other assessment we have a assignments you submitted through Google Classroom. Now we have a LMS, a learning management system. So our Satyabama LMS is there. So kindly go through it, and once I share my, I think you people can able to download the app in our Google Play Store. So you please, you are oftenly using mobile phone and all, na? Please upload it, and then for all the 4 subjects you have, everything you can access through it. Okay, so please kindly go through it, and today I will put up the assignment for you. So complete the assignment. Okay, so the first unit already we have discussed, we have completed the entire portion. So I have put the PPT, study material, everything for your purpose. So I will share some of the question paper tomorrow. Okay, this is the morning first hour. I thought you will be in a brisk mode, and we will move on to the second unit. Okay, so I think we'll move on to the second unit. Here we have second unit is about programming of 8051. So you can understand that the entire second unit is about instruction set, programming language, and uh, all the programs you will learn, and the instructions also, even it is assembly language programming. If you understand 8085, most of the instructions are same, similar to 8085 only. Some instruction only get changed. So we will see first addressing modes, then we will discuss about instruction set. After discussing about instruction set, we will see the program. Actually, the second unit is very very important. Why I'm saying, Anana, the same second unit you all do it in a lab. Okay, lab, we will do embedded and DSP design lab we have. So on that lab we will do 8051 programming. Okay, that is one mode. And another mode, we will generate the DSP signals. What you have studied, discrete signals, like exponential signal, um, or a unit step signal, sine signal, cosine signal, everything in a discrete. Okay, and the next one is we will do the signal generation using DSP processor. So this 3 kind of lab we will do. One is we will do in MATLAB, another we will do in Kale software for microcontroller, and another one we will do it in DSP processor. Okay, the kit is available, we will do. So we will see at what condition we will do the lab, all the labs, because we all know triple people can't able to do in the lab in online. We will try to match it out, and we will sort out the condition. So the second unit is very important, not only for the theory but also for the lab also. So you please try to understand the instruction set, because one thing you have to know, everything the memorizing will not help you for you to write the exam. So understanding the concept is only helpful for you. So today the most important question in the second unit is addressing modes. I think can you able to hear my voice? Yeah, okay. Address, yes, okay, thank you. Addressing modes we will discuss. Okay, now this is the course objective we have completed. We are aggregated to NBA. So our first course outcome is analyze the architecture and functional operations of 8051 microcontroller. So that we completed. Unit 1 relates CO1. So we completed the CO1. We analyzed the architecture and we studied the functional operations. That means inside of the microcontroller we studied about the ports, memory, then serial concepts, timer and counter, Okay, everything we have studied the functional operations inside the 8051 microcontroller. Now CO2. CO2 is what means course outcome 2. Apply the 8051 microcontroller for addressing the engineering problems. Okay, actually, by seeing this, you may understand what engineering problem you are going to solve. Actually, you understand the microcontroller have a applications in embedded. So most of the embedded applications, the microcontroller coding will be very useful. I told you while I'm designing the washing machine, exclusively they use the microcontroller. Okay, and using traffic light or in stepper motor, DC motor. So these are the main application. Even if I want to on and off of the switch using microcontroller, I can generate the pulse. So on the side, ma'am. Okay, so using that, we can sort out the engineering problems. Okay, so the unit 2 we were focusing. So today the first important question and foremost question, you understand this. In this first unit we have so many probability of question. They may ask architecture, or they may ask ports, or they may ask timers, or they may ask serial. So four different questions can be asked in first unit. But when I move on to the second unit, the probability of asking theory question is only two questions. One is addressing modes and another one is instruction set. Apart from that, they will ask only programming. Okay, so we are going to learn addressing modes or instruction. So addressing the question may be from addressing modes or instruction set. So the first very important question is addressing modes. So people remember, this is very important question and important part B question. I think you have studied the addressing modes in microprocessor 8085 and 8086. So we will slowly move on to the topic addressing modes. Okay, so that name addressing modes, I'm saying what is addressing modes. Okay, uh, data means what I'm giving my through my value data or value or whatever may be specified in the instruction itself, or it may be stored in register, internal memory and external memory. We have three memories are here. Sorry, two memories are there: internal memory and external memory. So internal memory, what is my capacity ma? 256 bytes data memory. External memory, what is my capacity? 64 kb. So my data will be specified in instruction. Okay, data will be, for example, if I put mvi a comma 45, now 45 will be my data. So I have to move my 45 to accumulator. So I can move my data to store in register or internal memory, that I told you, 256 bytes. Okay, ram memory. External memory 64 kb memory. How we were calculating 64 kb ma? 2 power 16. 16 is my what? Data lines. Okay, so addressing mode, the definition is, what is addressing mode na? The method of specifying the data to be operated by the instructions. The data will be specified how I have to operate that instruction, and how I have to operate that particular data, whether it may be from register, or it may be from internal memory, or it may be from external memory. That is called as a addressing mode. So the method of specifying the data to be operated by the instruction is addressing mode. Okay, so here we will see the types of addressing mode. Before entering into the types of addressing mode, we will use some of the terms here. So you have to understand. A stands for what ma? Accumulator. Okay, we all know accumulator is what ma? Primary register. It can handle 8-bit register, because our microcontroller is also 8-bit. My accumulator is also 8-bit. So it will store 8-bit data. Okay, the next one is B. B stands for what ma? B register. Okay, C means, don't assume it's a carry bit. Okay, sometime we will use C. The C means carry bit. Okay, then register or suffix n. Or register means, we all know bank registers are there. How many banks are there ma? 4 banks: bank 0, bank 1, bank 2, bank 3. So 4 banks are there, each bank having 8 registers. What is my 8 registers value ma? R0 to R7. So totally 4 banks now, each 4 into 8 what ma? 32 registers will be there. But you assume, how I will select this bank now? Some of them are unmute your mic ma. Okay. So totally 32 registers are there. So default it will select bank 0, or else I have to use my PSW 2 bits. They are specifically allocated for selecting the bank. 00 na bank 0 will be selected. 01 na bank 1 will be selected. 10 na bank 2 will be selected. 11 na bank 3 will be selected. So my selection of the bank register is mainly depends upon the 2 bits of PSW. Okay. Now DPTR. DPTR means what? Ma? Data pointer. You assume here this is the data pointer only the 16-bit register. We are not going to discuss about the register what we are involved in timer and all. We are going to see only DPTR related instruction. So DPTR data pointer 16-bit register. Okay. And I told you internal memory. Internal memory, what is the capacity? Ma? 256 bytes. So 256 byte. How we were classifying now? Upper, lower. Okay, lower is 120 bytes, 00 to 7F. Okay, and then the mainly allocating for the special function register the remaining 128 bytes, 80 to FF. We all know FF means what is the equivalent value in decimal. 255. So 0 to 255 now 256 locations were there. Okay, so I will use my memory from 00 to 7F. We all know how we were specifying the value in a memory. We will discuss. Okay, now we will directly go on to the types of addressing mode. How many types are there, ma? 6 types are there. I told you addressing modes is the one of the important 6-mark question. So please people listen carefully. Okay, it is very easiest one. So immediate register addressing mode, direct addressing mode, register indirect addressing mode, indexed addressing mode, implied addressing mode. So you people understand here you are not writing anything there. You are just watching. You are all know even the way how we were have to memorize everything now by writing only, by seeing or by reading won't will go into our mind. When I start writing only, everything will be stored in our memory. So people try to write the notes. Can you understand or not? Even we are sharing the PPT, we were giving everything, but if I ask some small question to you in intermediately, you can't able to answer spontaneously. Even you are the bright students. So people try to write the hint which is I'm giving. Even you didn't write, you just unmute your audio and tell me, ma'am, I'm writing the hint, please give a time. So I won't be changed on the particular slide. I will wait for some more minutes, then I will change. Are you clear? So 6 addressing modes are there: immediate register addressing mode, direct addressing mode, register indirect addressing mode, indexed addressing mode, implied addressing mode. Now we will discuss one by one. Okay, now first we will see immediate addressing mode. Okay, I think while we are discussing in some of the instruction, I told you this hash sign. See, in 8085 and 8086, we use the command MVI, move immediately. But here we don't have such a instruction. But the symbol hash, if I put hash, always the hash represent immediately I have to move the data to particular register, or I have to move to the particular memory location and all. So move R3 hash 45. Okay, just you understand the simplest method to get the data, whether it may be a 8-bit data or 16-bit data. We all know 8-bit data means 8-bit data will store only in 8-bit register. 16-bit data na 16-bit register will only hold the data. Here we are using 16-bit data register is only one register, that is DPTR, data pointer. It have a two 8-bit register, DPL, DPH. That means data pointer lower order byte, data pointer higher order byte. Data pointer lower order byte means what? It will take the bit location from D0 to D7. DPH means what? It takes the memory location from D8 to D15. So people try to understand, if I put hash, hash represents what? Immediate data. Immediately I have to move the data to the particular registers. So you just see move R3 comma hash 45. That means what? The data 45 should copy to R3. The next two instruction is move a hash comma 0AF. Why I put it's a 8-bit data only. Why I am putting 0AF? Kindly tell anyone, ma, because we have used the same concept in microprocessor.
Ma'am, before we are keeping that alphabets, we have to keep zero.
Very good, Supriya. Actually, while it has to recognize its alphabets A, B, C, D, F, we have to recognize it's a hexadecimal number. So before hexadecimal number, we should have to add 0. So AF means I am moving my data AF to accumulator. Can you understand? That is the value hash. Hash means what? Immediately I am moving my AF value to accumulator. The next one is DPTR. We all know DPTR is what, ma? 16-bit register. So I'm just moving DPTR to what is the value? 16-bit data. 4500 to DPTR. We all know DPTR as I can use as a 16-bit register or to 8-bit register. So DPH will hold 45 and DPL will hold 00. So this is the way I will have to use the hash symbol for immediate addressing mode. So immediate addressing mode, what is the symbol I have to use, ma? Hash. So move, that is the syntax. Move register comma hash 8-bit data, or move 16-bit register comma hash 16-bit value. Okay. The next addressing mode, register addressing mode. You understand, have register addressing mode. So the register addressing mode, what do you learn in 8085? Same thing only. What is the syntax we will use for move, ma? MOV, destination register comma source register. So I am moving my source register content to destination register content. That is the thing. So using this, my source register will not be altered. So my data available in my R5 is copied to A. Move R0 comma A, that means what? I have to move my accumulator content to R0. Then add A comma R5. Add A comma R5 means what? I have to add the accumulator add the content of R5 to content of A, and then add A comma R5. A comma R5 means what? A plus R5. We all know. But after adding, my results will be stored in where, ma? Accumulator itself. So after adding the all our arithmetic and logical operation, my results always stored in accumulator. So A plus R5 na, A plus R5 content, and the answer will be stored in accumulator. So register addressing mode means involves the use of register to hold the manipulated data. So I think they have given this permit to access 8-bit registers of register bank. So I told you how many register bank, ma? 4 register bank. So move A comma. So always remember what is the syntax for move? Destination register comma source register. So source register content is moved to destination register. R5 content is moved to accumulator content. Accumulator content is moved to R0 content, R0 register. And adding A plus R5, my accumulator will store the result. This is register addressing mode. Here no symbols involved. The first case we have put that hash, but here register addressing mode, what is the syntax, ma? MOV. MOV is the syntax. Okay, the next one is direct addressing mode. The third type we are going to discuss will be direct addressing mode. Direct addressing mode means address of the data is directly specified in the instruction. You have to understand the difference between the first instruction and the second instruction. Move R2 comma 45. Here what say, ma? Address of the data. We all know we have an internal memory as well as external memory. We all know internal memory, data memory, what is the capacity, ma? 256 bytes. 256 bytes means what? My address will vary to 00 to FF. So what is my address line? How many address lines will be there? 8 address lines will be there. But when I move to external memory, we were saying 64 KB. So obviously how many address lines will be there? 16 address line will be there. So try to understand, internal data memory have a 8 address lines and external data memory have a 16 address lines. Okay, but you have to move R2 comma 45. Don't think 45 should be moved to R2. If I want to move 45 to R2 means which symbol I have to use? Which
Hash.
hash? Very good. Hash. Can you understand the difference between the first instruction and the third explanation? Move R2 comma 45 na data stored in the location of 45 is copied to R2 register. Can you understand? So it will go to the address. 45 means that is specifying the address. Are you clear? I told you we have a upper and lower. Lower means what? 00 to 7F, that is 00 to 127 bytes, and SFR is 80 to FF. So here we have a address memory 00 to 1F. Beyond that only we will use the, I think once again I will share one more PPT, then uh, I will show you the image. Why I put this now? Even it I have thought 1 week before. You should not. I have to copy that. So people listen. This is 128 bytes. We used to say 128 bytes and another 128 bytes for SFR. So we always in the lower 128 bytes only, we will use it for internal memory. In the lower 128 bytes, 00 to 1F for 4 address bank, 00 to 07 for bank 0, 08 to 0F for bank 1, 10 to 17 for bank 2, 18 to 1F for bank 3. Can you understand? So this 32 bytes I will use only for 4 address bank. Okay. Then bit address area. Okay, that 16 bit they will use as a bit address area. So I can use it from 30 to 7F for general purpose area. So general purpose area means here I can use it as my memory. So if I am using my internal memory, that 80 bytes I can allocate for my internal memory. So normally I will use from 30 to 7F for my internal memory. Are you clear? So the other memory we won't use 30 to 7F. So how many address lines are there, ma? 8 address lines. 30 means we all know 30 how we will represent in hexadecimal. 0, how we will represent, ma? 0 0 1 1 0 0 0. Okay. 7F means for 7 how will you represent? 0 3 ones 1 1 1 1 and F 4 ones 1 1 1 1. So totally how many bits only we are using? 8 bit only. Can you understand? So this way only we will use the general purpose area for our storing of my data. 80 bytes they are allocating. Are you clear? Internally we will use only this memory for storing the data, or we have to retrieve the data and all. We will use this general purpose area for our programming. Okay, I will come back to the other PPT. Okay. So move R2 comma move R2 comma 45. Move R2 comma 45 means what? Data stored in the location of 45H is copied to R2 register. Okay. Now I put move R0 comma 05. 05 means I told you it is a bank register. We all know 05 means which register, ma? Anyone can tell quickly? 05 means which register content I have moving to R0? 00, what is the location of R0? 00. Then 01 stands for R1. 02 stands for R3. 04 stands for, you tell me, 00 for R0, R1, R2, R3, R4. So 01, 02, 03, 04, 05 means what is the location? R0, R1, R2, R3, R4. So which register ma we used to say? R05 specifies which register?
R4.
Yeah, R4. So R4 content will be moved to R0. Can you understand? So move R2 comma 45 means data stored in the location of 45H is copied to R2 register. Data or else the data stored in 05H location is copied to R0 register. That is direct addressing mode. Directly I am specifying the address. That's why this is called as a direct addressing mode. Directly I will specify. Okay. Now this is register indirect addressing mode. Previously I have specified my address directly, that is 8-bit address. This is register indirect addressing mode. What is the difference between that case and here? Now I will use at. This is the important symbol in this register indirect addressing mode. I will use which symbol ma? At symbol. So at symbol will always hold the indirect addressing mode. Or do you understand? So you have to understand this. I will directly move on to the instruction. Then we will come to that case. Move A at or not. If I put at means what? Indirect addressing mode. You such say move A at or not. We all know or not. What is the address? 00. I told you if I am not specifying anything, the bank 0 will be defaultly selected. So at or not means what is my or not value? 52. Okay. So what it will go now? It will go to the address of 52. And what is the data in 52 ma? 33. That will move to accumulator. This is called as a indirect addressing mode. You understand this? Move A at R naught. At R naught means what it will go? It will go to the R naught. In R naught, what is the value I am storing? 52. So 52 locations when it will go to the at R naught means it will go to the location of the 52. In the location of 52, what is the value stored in that location ma? 33. That 33 will move to accumulator. So move A at R naught means at R naught specify the address of the operand. Are you clear? At or not specify what ma? Address. Now I will move on to this instruction. You just see this instruction specify the name of the register in which the address of the data variables are there. Source or destination addresses given in the register. Okay. And A register is used as a pointer to the data. So I can use what ma? R0 to R1 for what ma? 8-bit address. So if I want to move a 16-bit address, obviously I have to use which register ma? DPTR. So DPTR will hold the 16-bit address and R0 to R7 will hold the 8-bit address. Okay. And here we are say they are specifically saying R0 and R1 only used for the address purpose. So R2 and R2 to R7 will not hold the address of an operand location. So I can use only R0 and R1 for 8-bit address and DPTR for 16-bit address. So I can use move A at R0 or move A at R1 or move A at DPTR. Only the valid 3 instructions for this at only R0 and R1 is used for 8-bit address. Okay. This is the I have explained you. Okay. The next one is the indexed addressing mode. Okay. Indexed addressing mode. Here we used to say at. Here what do we say now? C. Indexed addressing mode. C is nothing but a code memory. I will explain you with the example. Move C A at A plus DPTR. I think plus means what ma? It always perform a addition. Remember what is my accumulator value na? 02. Okay, now you go to DPTR. DPTR we all know 16-bit register. What is my 16-bit register value? 01FE. A plus DPTR. A plus DPTR means what? 02 plus 01FE. So what is the value ma after adding 01FE plus 02? So automatically what is my addition? 01FE plus 02, what is my value? 0200. It will go to the 0200 location. What is the value stored in that location? That value will move to accumulator. Once again I will represent But here C stores what now? Code memory. Okay. Actually, in the code memory, A plus DPTR it will calculate. A plus DPTR means what? Accumulator value plus DPTR. That will add both the value and it will calculate the address. And what is my address? 0200. In that 0200, what is the value stored? Ma? Data. That particular data will move on to the accumulator. So here C stands for what? Ma? Code memory. You always represent C stands for we all know we have two kind of memory, program memory and data memory. So this instruction only used to access the program memory. So far we have seen only with the data memory, but this is the first instruction to access the program memory. I am using this indexed addressing mode. Through indexed addressing mode I can access my program memory. Okay, so I can use DPTR register or I can use a PC register. PC means what? What is PC, ma? What is PC?
Programmable counter.
Ah, very good. So that is called as a base register. So A plus DPTR or A plus PC. Okay. So indexed addressing mode means that is the only addressing mode used to access the code memory or programming memory. Okay. Then next, the last one. I think you heard about this word implied addressing mode. Okay. So instruction itself specify how I have to operate my data. It is always a single operand. We have studied single byte instruction, 2 byte instruction, 3 byte instruction. Can anyone tell what is single byte instruction, ma? What is single byte?
Alphabets, ma'am. Only.
Single byte means a instruction will occupy only one memory. 2 byte na it will occupy two memories. 3 byte na it will consecutively occupy three memories. So here I am saying single operand. It's a single byte instruction only. That means we don't have any other data or will be specified here. Only the instruction will be specify how I have to handle my data. CPLC. CPLC. Here C means what? We don't have any C register. Always remember in 8051 C means C always specify carry flag. CPLC means complement the carry flag. Can you understand? So if I want to complement the CPL always stands for complement. Okay, we used there. Complement means whether the one means the value will become 0. 0 means what? The value will become 1. So complement the carry flag. Then swap. I think swap A. Can you able to see this swap A instruction? Okay. Swap. Swap means we all know accumulator. What is my capacity? Ma 8 bits are there. So we used to say lower nibble, upper nibble. Lower nibble means what? 4 bits. Upper nibble means what? Upper 4 bits. So we used to say D0 to D3 lower nibble and D4 to D7 upper nibble. Okay. So here swap A. Swap means lower nibble and upper nibble will be exchanged. You understand? Move A comma hash 72. Now only we studied what is hash ma? Immediate addressing mode. That means my accumulator value should be directly load with 72. So what is my value? A equal to 72. Swap A. Swap A means what? I have to swap my lower nibble to upper nibble. So what is my value? 72 means the value will become 27. That is called as a implied addressing mode. So we all discussed all the type of addressing mode. I told you addressing modes is one of the important questions, ma. Important 16 more question in the second unit. So I have given the summary of addressing mode. So what is addressing mode? I have told you that is how we are specifying the data, how we have to operate the data. That is called as the addressing mode. So we have a 6 types of addressing mode. Immediate addressing mode. Immediate addressing mode means what is the symbol I have to use? Hash. Move R3 comma hash. Hash R3 value should move to 45. Register addressing mode means what? My register. What is the syntax for move? Move comma destination register comma source register. So source register content should move to destination register. That means R5 content is moved to accumulator content. Direct addressing mode. Direct addressing mode means what? Directly I will specify the memory. Here we involves only the 8-bit 8-bit memory line, and it involves only the in on chip memory. On chip memory means we all know 256 bytes only. So my address lines will vary from 00 to FF. Now only we see 30 to 7F will be the general purpose area where I can store or retrieve my data. Okay, so direct addressing modes means move R2 comma 45 means 45 is what my address. So 45th location, what is the data will be stored, that will be moved to R2. So register indirect addressing mode. What is the symbol involved in register indirect addressing mode? At. So at is the symbol. So at is the symbol means at R0. So at R0 is the address of the operand. That will move 0 comma E5. Here 0 comma E5. E5 means they didn't specify the address. They specify the register of the address. I will show you E5 is address of which register. Okay. Then next one is move indexed addressing mode. Indexed addressing mode means what? A plus DPTR. A plus DPTR means what? I have to add my accumulator content with the DPTR content. It will show the code memory for where I have to fetch the data. That data will stored in the accumulator. Implied means single operand. We have only two instructions. CPLC, complement the carry bit or swap it. So immediate addressing mode means which symbol we use? Hash. Register addressing mode means what is the keyword? Move. MOV. Destination register comma source register. Direct addressing mode means what? Move register comma address of the location. Direct address of the location. Indirect means what? At R0 comma R1 or at DPTR I can use. Indexed addressing mode means what? A plus DPTR or A plus PC, that we use as a base register. Implied means complement C. Okay. I have put E5, 0 E5. What Supriya said. Before alphabets, we always put 0. Okay. Now we will see E5 specifies which I forgot to copy that. Okay. See, listen. Here, B na, what is the register address ma? F0. Accumulator na, what is the address? E0. PSW now, what is the address? D0. IP now, what is the address? 88. So instead of that, what they will do, they specify the register. Instead of that, they will specify the location of the address. So accumulator means default it will take the address E0. Actually, it is, I forgot to put E. It's not a E5, it's a E0 only. E0. B means, but every time we can't able to remember the address. But don't confuse on that, because you all know we will conduct only the objective type questions. So at least try to remember the address of the accumulator. What is the address of my accumulator ma? E0. So here, instead of specifying the address, what they will put ma? They will put the address of the register. Oh, sorry. Actually, I have to put what ma? E0 only. E0 only, address of what ma? Accumulator. Okay. So have you all understand the addressing modes ma? Immediate addressing mode. What is the symbol used in immediate addressing mode ma?
Hash.
Hash. Register addressing mode?
Move.
Move. Destination register comma source address. Okay. Direct addressing mode used to access which memory? Internal or external memory? Direct addressing mode.
Internal data.
Internal data. Actually, it will specify what memory ma? Internal memory. Okay. Register indirect addressing mode? At. The symbol is used will be at. Indexed addressing mode? What is the syntax? At only, but what we use A plus DPTR or A plus PC. PC we use. Okay. Implied addressing mode means it's a single byte instruction. So your people understand
Complement C.
complement C. Very good. Okay, so this is all about addressing modes. I think addressing modes you have studied. One of the important question. You think you can expect this addressing modes as a 16-mark question in this unit. The next question is instruction set. The left of the things are programming. So if you are strong in program, you can write the program, or else you can depend this two questions. One is addressing mode and another one is instruction set. So instruction set, we have uh, we have 5 types of instruction sets are there. Anyone can you able to tell arithmetic instructions? Kindly unmute your audio and tell arithmetic instructions now. What are the instructions we will see, ma?
Add A.
Add, subtract, then
Addition, multiplication.
here 8051 we have one very important instruction, mul and div, multiplication and division I do. So arithmetic instructions now it will do addition, subtraction, multiplication and division. Logical, what is the logical instructions?
And
Logic, very good. And or
not.
and or not, and the other function will do XOR. Very good.
And.
NAND and all we can't
No,
perform.
no, man.
And or exclusive or not, we can perform only this instruction. Actually what you learn in microprocessor, the same thing only. So and or and exclusive or, and then we can perform with the not functions and all. Okay, and rotate also will be there in logical instructions. Whatever we can do something. Data transfer, what is data transfer instructions, ma? One popular instruction in data transfer. Very good. Move. MOV is the popular data transfer instruction where used to transfer the data between registers. Now we have discussed at the addressing mode. Now same instruction only we will. Please kindly mute your audio, ma. Okay. Some of them. It will be disturbance to others also. Who is? So today 92 students were present. Oh my God, very big. Actually, I have to ask something. Vijay Kumar, are you present? Sagini Vijay Kumar. Izad. What problem for Vijay Kumar? He's not coming regularly, ma.
I don't know, ma'am.
You don't know.
His friend told some network problem.
Okay. Maunika, are you present today?
Yes, ma'am. Yes, ma'am.
Actually, you are taking some leave, ma, 2 days and all. You try to attend the class regularly. Okay. And Vanmati, are you present today? Vanmati? Absent today also. What happened to her, ma? Then Santosh Reddy, 89. Santosh Reddy is also not attending.
Ma'am, in his region there is no mobile network. That's why.
Where he is?
Yeah,
Which
network
location, ma?
problem, ma'am.
Network problem. Which city, ma, he's residing?
Warangal.
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 Warangal. Due to flood.
Yes, ma'am.
Heavy rain, ma'am.
No, ma'am.
We have to monitor your locations. We have to go and see what is the weather conditions and all. Okay, so people try to attend the class somewhat regularly. Okay, are you clear, ma? Rahul Singh is present today.
Yes, ma'am.
Why you are absent yesterday, man?
Ma'am, due to power cut, no network yesterday.
In mobile also you don't have a you're attending through Wi-Fi.
Yes, ma'am.
Yeah, if you have some power cut problem and all, kindly use your mobile data to attend the classes. Because attendance, they give some 5 marks for you. Out of 50 marks for internal, 5 marks for attendance. So please
No,
kindly, okay, don't give some simple reasons for you. So you try to, and Jagan, are you here, ma? 36 Jagan is present, but he will switch on his
Yes, ma'am.
Jagan, you didn't name your register, how you are named, na? Your name followed by the register number. Actually, register number followed by your name. So first put your register number, then put your name. Are you clear? So after the break, change it and attend. Okay. Okay. Next. So people, Boolean variable instruction. The fourth one is, I think this is the only instruction you didn't learn so far. The remaining and all, you have learned some things somewhere else. Okay. And the next two popular is program branching instructions. Anyone tell what is program branching instruction? What are the instruction we used?
Loop, ma'am.
Huh?
Loop.
Move is not a branching instruction. Move
Loop,
is
ma'am. Loop.
loop. We used to say loop. No, no. What is the ALP syntax I used? In loop, you are saying in C programming. Programming branching instructions. Anyone remember the name of the instruction?
Jump.
Very good, very good. Jump. Then
Go to, ma'am.
go to also again see. Jump. Actually, you go to we use as a label in 8086. Can you understand? Jump, call, return. These are the three popular instruction we used in the programming branch. Okay. So today we will see actually another important is instructions that I told you. See, remember, A stands for what, ma? This already accumulated. B stands for what? B register. C stands for carry bit. Rn means what? R0 to R7. Okay. And the memory locations, internal memory locations, they use totally 256 bytes. So 00 to 7F, lower 128 bytes, upper 128 bytes, 82 FF. Okay. At RNI, I told you at RI will specify the internal RAM address at R0 or at R1. Hash means what? Immediate data. Hash, I can use 8-bit data or I can use 16-bit. Okay. And ADDR11, I will explain you if I want to use the 11-bit destination address. 11-bit means what? Anyone can use? 8-bit means we all know internal memory. 16-bit we used to say external memory. But 11-bit is what? 0 to 4 KB memory we have studied the internal programming memory. Na? At that time, we will use the 11-bit destination address. So while I am discussing about a branching instruction, we will see. Okay, the remaining and all. Okay, so data transfer instructions, there are 4 types are there. Registers, internal, my data will be between the registers, between internal memory, between or it may be external program memory or external data memory. So MOV supports to transfer the data between the registers, between the internal memory or external program memory or external data memory. What is internal memory capacity, ma? Aarti, what is internal memory capacity? Aarti. Shanmuga, tell. What is internal memory capacity?
256 bytes, ma'am.
256 bytes. Okay, very good. External program memory? External program memory.
16 KB, 4 KB, 64 KB.
64 KB. Okay, actually 64 KB only. But on that 64 KB, 4 KB I can use as my internal memory. External data memory also? What is the capacity?
4 KB.
External data memory.
128, ma'am.
Hello. External data memory, that is also 64 KB. Remember, always remember, internal memory 256 bytes, internal data memory 4 KB ROM, that is program memory. We have a 2 memories are there, that's why we are saying Harvard architecture. Okay, program memory, data memory. So internal program memory is 4 KB, internal data memory is 256 bytes, external program memory is 64 KB only. Okay, and external data memory also 64 KB. In the external program memory 64 KB I'm saying now, and that 60 KB they will use it as a external program memory. 4 KB whether I can use as a internal or external. Are you clear? Okay, I think tomorrow we will see about the data transfer instructions. I think after a long back I'm going to take the attendance. kindly unmute your thing. 1, register number 1, Aarti.
Yes, ma'am.
2, Abhinami is present. Okay. 3,
Yes, ma'am.
4,
Apasar, ma'am. Apasar, my dear.
yeah, present. Ajit Kumar, again you have so much
Present,
of
ma'am.
network problem. So many times you are log in and log out. Nearly some 10 to 15 times. Don't do that. Try to no. Ajit Kumar. Actually, I'm not saying one day I have seen so many times you have logged in and logged out. We will get how much time you are in. So at that time we will calculate and will take the attendance. Akash, 5,
Yes, ma'am.
6,
Yes, ma'am.
7,
Present, ma'am.
8, 8 ma, 9,
Present,